Students, good morning all. So today we are going to discuss a new topic. Hope you all are doing good and hope the previous classes were helpful for you. Okay, so now today we are going to discuss about a new topic, and actually first of all I welcome you all to APJ Academy. And okay, now here is all about our full year course. You can see that what all sessions we are promising you. Okay, so there is PDF materials, 25 major test series will be conducted for you. There will be query solving will be there, and we will be giving you lectures, lessons, topics will be taught thoroughly, and there will be always be a assignments provided to you in order to develop your analytical skill as well as your problem solving skill. Okay, right? Yes. Yes, students, you can see an enormous discount over here. You can crack the JEE or NEET with this much enormous discount. Okay, yes, it is only 490 rupees per month. It is 490 rupees per month. Okay, right. Okay, students, you can see an enormous. Yes, sorry for that. Okay, now here we have free regular classes for APJ Academy. Hi Nisha. Okay, in our YouTube channel, so you can just subscribe to the YouTube channel if you are new to this. Okay, yeah, and that's all about me. Okay, you have been listening to this in the previous classes also, so this is all about me. Now let's start with the topic. Today we are going to discuss about the Bohr atomic model. It's an important topic, you know that, and we now started the second chapter. Okay, it is from the atomic structure. So atomic structure, we have different atomic models to be learned. So in that, the very first one we are going to discuss about the Bohr atomic model. Okay, now let's see what Bohr says about his atomic model. We know that Bohr model is only applicable for single electron species. So say, what do you mean by single electron species? That means an atom with a single electron, or an atom or an ion with a single electron. So hydrogen is the only atom in the atomic form which consists of single electron. If you take helium, lithium, or any other elements, they consist of more than one electron. So they cannot show Bohr, the Bohr model is not applicable for them in their atomic form. Rather, they can be in their ionic form, so that the Bohr model will be applicable for them, because the Bohr model is only applicable for single electron species. That's the most important point. Okay, now Bohr model is based on the particle nature of electron, and we also know that the electron have dual nature, right? So it has wave nature as well as it has particle nature. So here the Bohr model is entirely based on particle nature, because Bohr couldn't recognize the wave nature of electrons. So this is entirely based on the particle nature of electron. Okay, so later on the Heisenberg principle and dual nature came into theory. We started to identify, okay, the dual nature of matter and dual nature of electron, that it does not move on the straight line, it have a wave nature, it moves like a wave along the orbits of the atom. This is what we learn from the wave nature of electrons. So there are dual nature, it shows the particle nature as well as it shows the wave nature as well, right? Okay. Now, what are the important postulates that you have to understand or you have to learn from this Bohr model? The very first one is electron revolves around the nucleus in a circular path known as orbit. Okay, so we know that this is an atom, and here we have the nucleus in the center, and the electrons are revolving around the nucleus in circular orbits. See, in Rutherford also, in Rutherford also, in Rutherford's atomic model, you have studied almost the similar concept that nucleus is concentrated at the center of the atom and electrons is revolving around it at fixed orbitals, right? But there was a problem with Rutherford's model that he couldn't explain the stability of the atom. What do you mean by stability? That means the Maxwell theory was there. What Maxwell told was that whenever an electron starts revolving, it uses its kinetic energy, and what happens is that it starts to lose its energy, and after losing its energy, it goes on revolving and loses its energy, releases the energy, and finally it comes and fall into the nucleus. See, it comes and fall into the nucleus. If that happens, the atom cannot be stable, or the atom will completely get destroyed. You know that the basic particle of the whole nature or the whole universe is atom. So if every atom have the similar situation, then the world cannot exist by its own. So atomic stability is not a simple thing to discuss. Atomic stability has wide range of effects on our life, day-to-day life. Okay, so the world is existing means every atom is existing. That means the electron is revolving, but still there is no loss of energy of electron. So this theory, this Maxwell's principle was not explained, or the stability of the atom couldn't explain by Rutherford. Then Bohr came into the picture. Bohr said that yes, there is a concentrated mass at the center of the center of the atom, that is called as nucleus, and the electron is revolving around it. But what Bohr said is that the electrons are revolving around a fixed energy orbits. It is in the fixed energy orbits. The energy is present in the orbit and electron is revolving in that energy field. If that energy field is there, then electron cannot utilize its energy. Electron is not utilizing its energy, but a force, an energy field of the orbit is pushing the electron to revolve around it. So the equation is so clear and the concept is so clear that is the reason why electron do not use its energy to revolve, because the orbit is having a special energy, or the orbit is having an energy field, and when you keep an object in that energy field, it starts revolving. So there is no issue of stability. The stability is maintained. There is no issue of releasing of energy. So this is the basic concept that students have to understand. I know that many students used to write these limitations in their exams, that Rutherford cannot explain the stability, but none of the students know what actually is the stability. So this is related to the Maxwell theory, that Maxwell told that if the electron is revolving, then obviously it uses the kinetic energy. Yes, if velocity is there, we have studied in the physics, if velocity is there, then obviously there will be energy. So energy, it cannot be conserved. That means it cannot be in the same state. Energy is conserved. That is, it from one state to another state it forms. It transforms, right? So energy cannot be there as kinetic energy throughout. It gets transformed to kinetic energy, from kinetic energy to heat energy. That's why the energy goes on releasing. The energy goes on decreasing. And as it goes on decreasing and it reaches to zero, the nucleus is continuously pulling the electron. So the electron will go into the nucleus and it gets completely destroyed. If that happens, okay. So if the velocity is there, then there is a centripetal force which keeps the electron away from the nucleus, and there is a nuclear force which always attracts the electron towards the nucleus. So this equal and opposite forces is keeping the electron in that particular orbit. So this is a concept about the electron revolving around it. Hope this is clear, student. Yes, Alex. Okay. So that's the very first point you have to consider, and let us discuss about the second one. So hope the stability concept is clear for you. So what Bohr said is that if the electron is revolving around the nucleus in a circular path, that path is called as orbit. That orbit have a constant energy field, and if you place an electron in that energy field, it starts revolving. Okay, now let's move on to the second one. What is the second postulate? Second postulate is electron can revolve only in those orbits. in which angular momentum of electron is integral multiple of h by 2 pi. See, this postulate was one of the limitation of Bohr also. You know why? Because he couldn't explain why he took the integral multiple, the angular momentum of electron as the integral multiple of h by 2 pi. He simply used the term h by 2 pi. He used the term h by 2 pi because he got some constant value similar to the value of h by 2 pi. So he used h by 2 pi. But he couldn't explain why that constant came in the relation. Okay. So what he said is that he only thing he wanted to explain was that the orbits have a constant energy. Okay. There is a constant energy field in each orbit. That orbital energy will be different for if you are starting from s orbital or p orbital, or if you are starting from k shell, l shell, m shell. Each orbit or shell have different energy, but each have constant energy. That means constant energy means the energy is not released or energy is not absorbed. That is constant there. Okay. So that's the concept what Bohr want to convey to us, right? So electron can revolve only in those orbits in which angular momentum. What is the angular momentum? Angular momentum equation, we know that mass velocity into radius. So the angular momentum of an electron is integral multiple of h by 2 pi. We know that the linear momentum, what is the formula of linear momentum? We know that it is P is equal to mv, right? So if you are considering about the angular momentum, then we know that we have to multiply this angular momentum equal to linear momentum into radius. Okay, radius means distance from nucleus to that orbit. Okay, so angular momentum is equal to linear momentum into radius, right? Okay, now what Bohr said is that this angular momentum, that is mvr, is equal to the integral multiple of h by 2 pi. mvr is equal to an integral multiple of h by 2 pi. What do you mean by integral multiple? That is, it can be 1h by 2 pi, it can be 2h by 2 pi, it can be 3h by 2 pi, it can be 4h by 2 pi, and he also explained that that integer, it is integral multiple, it cannot be any fraction. It cannot be any fraction. That is an important point you have to remember here. That is, the n value can always be an integer, that is 1, 2, 3, etc. It cannot be n equal to 1.5 or 2.5. It cannot be like that, right? So n equal to 1, 2, 3, etc. is the only way. That is, the possible values for n is only 1, 2, or 3, etc. Right? Okay. Now here I told you mvr is equal to nh by 2 pi, and h by 2 pi is a constant and it can be replaced by another constant, that is h bar. You can use the term h bar. So h bar means it is h by 2 pi. So h bar also you can utilize. In certain question paper you will see the representation of h bar. So whenever see the representation of h bar, don't get afraid. Okay, it's just simply means h by 2 pi. Okay, and we know that where n is the positive integer number, that is n is equal to 1, 2, 3, and h is the Planck's constant. Okay, h is the Planck's constant. Hope these two postulates are clear for you guys. So let's think about the second postulate. The electron can revolve only in those orbits in which the angular momentum of the electron is integral multiple of h by 2 pi. So there will be lots of orbits. Okay, we know that there are lots of orbits, but electron do not choose any orbit which do not satisfy this condition. What is this condition? It says that the angular momentum of electron can be 1h by 2 pi, it can be 2h by 2 pi, it can be 3h by 2 pi, it can be 4h by 2 pi. It should be integral multiple. But it cannot be a fraction, that is, it cannot be like 1.5 h by 2 pi, 2.5 h by 2 pi, 3.3 h by 2 pi, 7.2 h by 2 pi. Like that, it cannot occupy such orbits. It only occupies those orbits where the angular momentum of the electron is the integral multiple of h by 2 pi. And I told you there was a limitation regarding this. He couldn't explain why he took h by 2 pi. why the constant h by 2 pi is taken, or why it came as the integral multiple of h by 2 pi, why not the other value? So that was the limitation, one of the limitation of Bohr model, right? Okay. Now, as I have told you that if n is equal to 1, then the angular momentum of the electron will be h by 2 pi. What do you mean by n equal to 1? N equal to 1 means the first shell. Okay. N equal to 2 means the second shell, the angular momentum of electron will be 2h by 2 pi. Okay. As the number of shell increases, the angular momentum of that electron in that particular shell also increases. First one it is h by 2 pi, second one is it's 2h by 2 pi, then third one it is 3h by 2 pi. Likewise, the angular momentum increases. So, as the angular momentum increases, you can also understand that the energy of each electron is increasing, or the energy of shell is increasing as you go away from the nucleus. And this also was a basic concept regarding that. Okay, regarding the stability of an electron. That means if the electron is nearer to the nucleus, consider this as nucleus and this as electron. If it is nearer to the nucleus, it is experiencing a strong electrostatic force of attraction from the nucleus. So as it gets more attraction towards nucleus, this electron becomes more stable. If an electron or a compound is more stable, means it is at its less energy state. See, if you go to a marriage, if you eat so much that your stomach is too full, do you feel stable or unstable? Obviously we feel unstable, right? So what you have to understand is that stability always lies in less energy state. So when the electron is nearer to the nucleus, that means they are experiencing a stronger electrostatic force from the nucleus. So this electron will have the lowest energy, that means it is the most stable electron. If you move away from the nucleus, it starts to experience an energy, or it starts to experience an attraction which is lesser attraction. That means they have more energy, they have less stability, so they have more energy. So stability is connected to the energy. Less energy, more stable. More energy, less stable. This is a basic concept you have to connect with this theory. Okay. So, and here, as I told you, as we move on, go away from the nucleus. See, first shell means it is the nucleus is our center, and from the center, first shell means it is the nearest shell from the nucleus. That's what you have to understand here. Okay, that is n equal to 1 equal to h by 2 pi. If n equal to 2, it is 2h by 2 pi, and if n equal to 3, it is 3h by 2 pi. So, as you move away from the nucleus, your energy increases, right? Your frequency increases. So energy increases, or the angular momentum increases, means the energy is increasing. So it becomes 3h by 2 pi. Okay, and I have told you that n cannot have any fractional value like 1.5 h by 2 pi or 0.5 h by 2 pi. Like this fractional value cannot be found in the Bohr orbits. Okay, that's an important point. And the orbits in which electron can revolve are known as stationary orbits. See, it is called as the stationary orbits, the orbits in which electron can revolve. They are stationary orbits because in these orbits, energy of electron is always constant. This is what I told you. As they move, electron's energy is constant. Electron is not utilizing any of its energy to revolve around it, around the nucleus. These are stationary orbits, and these stationary orbits are energy fields. They are energy fields. They have constant energy, and electron do not utilize these energy, as these are what? As these are stationary orbits. Okay. See, if for example, I'll give you an example that it starts revolving. It's a special case. Just think about this, that if an energy field, if you are sitting in a slide, okay, if you are sitting in a slide, you know the slide in the water theme park, you know the slide, right? A circling slide, and water gushes out with a high velocity, and that water gushes out, and the water is flowing through that slide, and that is the energy field here, and that energy field is pushing you to move through that. Are you utilizing any of your energy? No. What is acting here? The energy that is passing through the slide is pushing you, it is helping you to slide. Okay, if the friction is very, very low, or if a hypothetical case we can take, if the friction is 0, then what happens? You move so smoothly, right? This is what happens with the electrons revolving in the constant energy field or the stationary field, right? Okay. Now, as I have told, and these orbits are numbered as 1, 2, 3. These orbits are numbered as, that means these orbits are called as the shells, or it is also represented as KLMNO. Actually, there are 7 shells. We actually, according to the present scenario, we know 7 shells: K, L, M, N, O and P. Okay, P, Q, 7 shells, because we know that in the periodic table there are 7 periods and each period is representing each shell. Okay, so first period we know that there is hydrogen and helium, and in hydrogen and helium the electrons are present in the first shell. That means the valence electrons are present in the first shell, that is from the nucleus, that is they occupy the K shell. In the second period means the electrons occupy the L shell. Okay, valence electrons, I am talking about the valence electrons. In the third period means the valence electrons are occupying the M shell. Okay, so likewise we have 7 periods which is connecting with the 7 orbitals or 7 shells, okay, where the valence electrons occupies. This is what you have to understand. Now, see, n is equal to 1 is the K, that is the first shell, that is also designated as the ground state. Okay, then n is equal to 2 is the second shell from the nucleus, that is designated as L, and which is the first excited state. You know that if this is the nucleus, this is our first shell and this is our second shell. If an electron is present in the first shell, then if the electron absorbs certain energy and it can move to the second shell, and this shell we normally call it as excited shell. Okay, excited shell, that is the shell to which the first shell electron got excited. So here you have to understand that in order for an electron to excite to the second shell, they require to absorb certain amount of energy. Why so? Because I have told you, as they move away from the nucleus, their stability decreases, their energy increases. So in order for the electron to move to the higher energy shell, they have to absorb certain energy, and they have to, then only they can move to the second energy shell. Okay, now what about n equal to 3? N equal to 3 corresponds to M shell, that is represented as second excited shell state, and n equal to 4 corresponds to the N shell, and that is the third excited state. Okay, so the emission or absorption of energy in the form of photon can only occur when electron jumps from one stationary state to another. And it is, see, I have told you that for an electron to jump from one energy state, that means first shell, let me change the color here. Okay, from the first shell to the second shell, what they have to do? They have to increase their energy. So in order to increase their energy, what they have to do? They have to absorb energy. So from where they get the energy? They get the energy from the photons. This is the photon, this is a photon. So they absorb a particular energy photon, and what they does is that they jump to the next energy level. So the electron only absorb or release energy. Their absorption of energy or releasing of energy only takes place when they jump from one shell to another. That means for encircling or for revolving around the nucleus, it does not require any energy. Okay, it only requires energy, or it only releases energy when it jumps from one state to another state. Yes, Kundan Das, good morning. Okay, so for this electron to jump from the n equal to 1 shell to n equal to 2 shell, it requires energy, it absorbs energy. So I have told you the second shell have more energy. So electron The first shell is more stable, so it will be at the minimum energy. So in order to get to the second shell, they require energy. So at that moment only the electrons absorbs energy. For revolution revolving around the nucleus, it does not require any energy, as we have told in the starting of this lecture. And if this electron wanted to jump back, if they wanted to jump back to the normal state, okay, if it wants to come back to its first state, what they have to do? They have to release energy, because we know that here it is high energy and in the first shell it's low energy shell. So you have to release that energy. That means the photon is released. The energy is released so that the electron can jump to the next, that means to the shell that stands below. Okay. So if it jumps from one energy shell to another energy shell, there will be a difference in energy, right? We have to calculate how much energy it requires to jump from one shell to another shell. That energy is called as the delta E. So in order to calculate delta E, this is the formula. That is E higher. Higher means higher shell. We know that the higher shell have the higher energy. Okay. E higher minus E lower. What is lower? See, if this is n equal to 1 and this is n equal to 2, that means the second shell is having more energy because it is away from nucleus. Okay, the second shell is having more energy and first shell is having less energy. So for an electron to jump from first shell to second shell, how much energy it requires? It only requires the energy difference. How much energy is different? How much energy difference is present between the second shell and first shell? That is, we consider it as delta E. And that delta E amount of energy is required for an electron in the first shell to reach to the second shell. Okay, so to calculate the amount of energy it requires to absorb or to release, I told that absorption, it takes place when electron jumps from lower energy to higher energy shell, and releasing of energy takes place when the electron jumps from higher energy shell to lower energy shell. Okay, so here it is energy at higher minus energy lower, that is En2 minus En1. N2 stands for the second shell, N1 stands for the first shell. Okay, now we will move on to the next one. See, I have told this, already explained. Energy is absorbed when electron jumps from inner to outer orbit, and is emitted. Energy is emitted when electron moves from outer to inner orbit. Already we have explained that concept. Now we will move on to the next one. Now here we are going to discuss about the application of Bohr model. See, we have different applications. So first one is to find out the radius of the orbits. So that means radius means the distance of the orbit or the shell from the nucleus. Okay, that is called as the radius. As I have told you earlier, there is an attractive force. See here, if this is an orbit and this is the nucleus, and here we have an electron. Okay, so we know that there is an attractive force between these two, nucleus and electron. What kind of attractive force? Electrostatic force of attraction. As an electron revolves around a circular path, it always experiences a centrifugal force, right? And that centrifugal force means it will be attraction. One is attraction towards nucleus, and this centrifugal force is directed outward. Okay, centrifugal force is directed outward. As it accelerates or as it moves along a circular path, a particular electron will experience a centrifugal force that is outwards. So see, I can explain you in your simple language what centrifugal forces. You will get that feeling. I know that you normally travel in a bus, right? When the bus turns towards the left, your body moves towards the right. Have you experienced that? Yes. Whenever the bus turns, that means it was moving in a straight road, and when it started to move towards or enter towards a circular path, you know that the bus is directing towards left, but you automatically move towards right. That means there is a force which balances you. That force is outward force, right? actually the bus is moving inward towards the left, but the force is applied on you, that which you experience that you are moving outwards, that particular force is called as the centrifugal force. So whenever a particle moves around a circular path, it experiences an outward force. That force is called as a centrifugal force. So here we can see that two forces are acting on the electron. One is the nuclear attractive force, which is pulling the electron towards the nucleus. One is the centrifugal force, which is pushing the electron away from the nucleus. So when these two forces are of equal magnitude, the electron revolves in a certain orbit, in a particular orbit, when they are equal and opposite. So that is the particular orbit where electron lies. Wherever the centrifugal force and the electrostatic force of attraction are equal, that is a particular orbit where the electrons start to revolve. And what Bohr said is that that particular orbit will be an integral multiple of nh by 2 pi or h by 2 pi. Okay, can you connect that? That's where while you are preparing for entrance, you have to connect all these one. All these you have to connect and you have to build the proper conceptual clarity. Okay, so hope that is clear for you. So from that I am not deriving it. Instead we do not require any derivation, but we require the formulas. Okay, so R is equal to n square h square by 4 pi square m k z e square. So you know that n means number of shell, h means Planck's constant, pi is a constant, m is mass, k is 1 by 4 pi epsilon 0, that is electrostatic force, the constant for electrostatic force, and z is the atomic number, e is the charge of electron. So these terms we are very familiar about, and if you substitute those values, I hope you cannot see that, right? Because there was an icon there, there was a bar standing in between, there was a bar right in clearly above that box, I think so, right? Is it visible for you? The value is visible for you? Please let me know if it is visible for you. Okay, so the radius, the formula after applying all the values, let me rub that. We apply all the values, all the constant values. That means here h Planck's constant we know, pi value we know 3.14, mass of electron we know, this is 9 into k values 9 into 10 raised to 9 and 10 raised to 9 into 10 raised to minus 9, and z is, we know that z it depends on the atom, so z we keep it as it is, and charge on electron we know that 1.6 into 10 raised to minus 19. All these values we know, and we apply those values and we get the answer as 0.529 into n square by z, that much Armstrong is the radius. So this is the first application of Bohr model. You can find out the distance between the nucleus and the particular orbit where the electron lies, and the equation is R equal to 0.529 n square by z, and that much Armstrong. 1 Armstrong is equal to 10 raised to minus 10 meter, or you can write it as 10 raised to minus 8 centimeter. So this also you might have studied in physics from the first chapter. 1 Armstrong is equal to 10 raised to minus 10 meter or 10 raised to minus 8 centimeter. From here you have to conclude this by writing this relation, that radius is directly proportional to number of the orbit divided by the mass number. Okay, no, sorry, mass number, it is atomic number, z is the atomic number, sorry for that. So radius is directly proportional to n square by z. Is it clear, students? Is it clear for you? Please let me know in the comment section if this concept is clear for you. Okay, if you have any doubt also, you can parallelly ask to me so that I can clarify now itself. Okay, so this is all about the radius. Now we will move on to the next one. Okay, that is the velocity of an electron. Now we know that there is centrifugal force, there is electrostatic force, and both are equal. So centrifugal force and electrostatic force, we equate them and we get the relation that velocity is equal to 2 pi Pi is a constant, K means electrostatic constant, Z means atomic number, E means charge of electron, divided by N means number of orbit, and H is Planck's constant. So you give the values of those constants you know, and this much constant, that is pi value we know, K value we know, E value we know, H value we know. So by applying all the constants there, we get the value of velocity is equal to 2.18 into 10 raised to 6 Z by N, that much meter per second. So from this relation, you have to remember that velocity is directly proportional to atomic number, and it is inversely proportional to the n orbit, number of orbit. Okay. So as you move away from the nucleus, the velocity start to decrease. As you move closer to nucleus, if the orbit stands closer to nucleus, the velocity will be high. If you move away from the nucleus, the velocity will be less. That's what this equation means. So in the previous slide also there was a relation. What was that? Radius is directly proportional to n square by z, and here we have z by n. So these two relation you have to remember it. Radius is directly proportional to n square by z. Hope this is clear for you guys. So these two relation, please remember this. It is very important while you start solving the numerical problem. Okay. Now time period. Third one is time period. What do you mean by a time period? See student, here this is our orbit and this is the nucleus. What do you mean by time period? So let's start. See, assume that the electron is present here and it start to revolve around the nucleus like this. It goes and it reaches the initial point. So the time taken by the electron to reach the initial point is called as a time period. That means the time taken to complete one revolution. It is revolving, and to complete one revolution, how much time it take? How much time it took to complete one revolution, that is called as a time period. So time period, we can find out the time by distance by velocity. We know that distance is equal to speed by time, or speed equal to distance by time. So time is equal to distance by speed. Okay, so we know the equation. Distance means this is the circumference. We know that circumference of a circle is 2 pi r, right? Here we use 2 pi, r means radius of the orbit, which orbit you are calculating, that particular orbit, divided by velocity. Here these are constant, so I can write it as time period is directly proportional to radius by velocity, and we just wrote that radius is directly proportional to n square by z and velocity is directly proportional to z by n. So time period will be directly proportional to this n square by z. Denominator will inverse itself and it becomes as n by z. So we can write it as time period is directly proportional to n cube by z square. So this is all about the time period relation. Okay. So as the number of shell increases, consider from the equation you have to develop the concept also. As the number of shell increases means the distance from the nucleus and the shell is increasing, right? R is increasing. That means the circumference is increasing. So time period increases if the circumference increases. Okay, and time period decreases if z increases. Time period decreases if z increases. You know, if the z atomic number means the atomic number is related to the attractive force. Means what do you mean by atomic number? Atomic number indicates the number of protons inside the nucleus. Okay, so if the nucleus charge or the nucleus number increasing, what does that mean? The nuclear attraction is increasing. As the attraction increases, the velocity increases. As the attraction increases, time period decreases. If velocity is increasing, what does that mean? Time period decreases. Okay, so that's the point you have to remember here. Connect it with the concepts, pure concepts. That's what take you to AIIMS as well as to IITs. Okay, This is how you have to learn chemistry. It's so interesting. Once you connect all the concepts and clarify, you should feel the subject, then you start enjoying the learning process. Okay, that's what we expect from each IITian as well as an AIM student. Now, getting into the frequency of revolution. So, what do you mean by frequency? Frequency is, if you consider a unit time, okay, in that unit time, how much revolutions it takes. Say, if I take a unit time as 1 minute, if I take the unit time as 1 minute, this is an hypothetical time, okay, 1 minute, because we know that the electrons move with such a velocity that in 1 minute and all, it revolves billions of times, right? So, let's say for the explanation purposes, I consider the unit time as 1 minute. What do you mean by frequency? In that 1 minute, see if the electron is starting from here, okay? In that 1 minute, how many revolutions does it complete? That number of revolutions is called as a frequency. How many revolutions it complete? Maybe in 1 minute it completes, say, in 1 minute it completes 100 revolutions. See, then the frequency is 100. See, if you can say that, let's consider this is a 200 meter circle, and we know that our beloved Usain Bolt is standing here. Okay, now Usain Bolt starts running. For completing 200 meter, he only requires 20 seconds, right? He only requires 20 seconds. So in 1 minute, how many revolutions he takes? In 1 minute, how many revolutions he takes? He just takes 3 revolutions. That means the frequency of his revolution is equal to 3. That is, frequency of his revolution is equal to 3. And you have to remember that frequency is equal to velocity by distance. Velocity is velocity with which it runs, or with which Usain Bolt runs, and then distance is the circumference, 2 pi r I. So we get an equation. Another relation is that frequency is equal to 1 by time period. Frequency is equal to 1 by time period. Frequency is inverse of time period. Hope this is clear, students. So these two equations you have to remember, and the most important equation is given here, that is, frequency is directly proportional to z square by n cube. As the number of atomic number increases, I told you, as atomic number increases means number of protons increases. If number of protons is increasing, the nuclear attraction increases. If nuclear attraction increases, the velocity increases. If velocity is increasing, that means the frequency also increases. So that is why frequency is directly proportional to z square. And you can see that it is inversely proportional to number of cube of the number of orbit. As the orbit is increasing, that means the distance from the nucleus and that orbit increases. That means the circumference or the distance increases. If the distance is increasing, it takes more time to complete one revolution. So frequency decreases. Hope this is clear, students. Please don't get confused, right? Please let me know if it is clear for you. Yes. Now we are going into the most important segment of this session, that is the questions. Hope you will enjoy this as well, right? Yes, students, I am waiting for your comments. Is it clear? Okay. Yes, now let's do this problem. That is, calculate the radius ratio of first orbit of helium ion to second excited state of lithium 2+ ion. Okay, I couldn't see any of your comments, so I'm just continuing with my lesson. Okay, now calculate the radius ratio of first orbit of helium to the second excited state of lithium 2 plus ion. So we know that radius is directly proportional to n square by z. We know that as the number of shells increases, the circumference increases, or the distance from the nucleus to that shell increases. So let's write it is the first orbit, right? It is the first orbit, that means for helium plus it is the first orbit, that means n equal to 1 for helium. So our helium, radius of helium is corresponds to 1 square divided by, what is the z value? Hydrogen, helium, z is 2. So it is equal to 1 by 2, right? So we can write it as it is equal to 1 by 2. Now what about the case of lithium? For lithium, it corresponds to the second excited state. See, it is the second excited state. That means you have to be aware of these terms. I have told you this is the ground state. First shell is the ground state and second shell is the first excited state. Okay. Normally student take here, this third shell is the second excited state. So these terminologies you have to be aware of. If not, instead of taking n equal to 3, you will take n equal to 2. So always be aware of such terminologies. The first shell means it is the ground state. I have already explained that before. The first excited state means it is n equal to 2. Second excited state means n equal to 3. And ground state means n equal to 1. So second excited state means n equal to 3 you have to consider. So here the value will be 3 square divided by the atomic number of lithium. Hydrogen, helium, lithium is 3. So you can cancel this 3 and this 3. So you will be getting 3 by 1 or 3 as the answer. Okay. Now what you have to do? You are asked to find out the radius ratio. So radius ratio of helium plus divided by radius of lithium 2 plus. So what was the radius of helium? That is 1 by 2 divided by lithium, it is 3. So you will be getting a ratio of 1 by 6. Yes. Yes students, that's the answer for the first question. Now let's move on to the second one. Okay. Calculate the angular momentum of an electron. You have to calculate the angular momentum of an electron, radius, circumference and diameter. Diameter means if you find out the radius, then just 2r will give you the diameter of the third orbit of lithium 2 plus. See, we know that angular momentum, what was the equation of angular momentum? That is mvr is equal to nh by 2 pi. So here we are given that it is third orbit. So we can substitute 3 here. So it will be n equal to 3. So 3h by 2 pi. Okay. Now see, that is the value of mvr, that means angular momentum. So we got the value of angular momentum as 3h by 2 pi. Now we find out the radius. What is the equation for radius? Radius is equal to 0.529 into n square by z, right? So 0.529, n means what? N means the number of shell, that is 3. So 3 square divided by z. Here we have considered lithium. The atomic number of lithium is 3. Okay. So you can cancel 1 3 and 1 3 here. So we will be getting 0.529 into 3. 0.529 into 3, that is equal to 1.587. That much Armstrong. Always remember this equation is in Armstrong. The unit is in Armstrong. If you want to convert into meter or centimeter, I have given you the relation that 1 Armstrong is equal to 10 raised to minus 8 centimeter or 10 raised to minus 10 meter. This is how you convert it into centimeter or meter. So no problem here. So if you get the answer in Armstrong, you can convert easily. Okay, it's not a big deal. Now what about the circumference? Circumference means it is purely mathematics. We know that encircling area is a circle. So the circumference is 2 pi r. So 2 pi, 2 into 3.14 into r, we have just obtained at 1.587. That much Armstrong. So if you calculate the value, you will be getting 9.96 Armstrong. Right. Now the third one is All about the diameter, we know that diameter is equal to 2r, that is equal to 2 into 1.587 Armstrong. That means it is equal to 3.174 Armstrong. 3.174 Armstrong. So hope this is clear, students. It's an easiest question, right? So all the concepts you are putting together in the question. So first one, they asked about you the angular momentum. You know that the angular momentum, the Bohr said that the angular momentum will be such that it will be integral multiple of h by 2 pi. So whenever you are asked to find out the angular momentum, h by 2 pi, integral multiple of h by 2 pi, then you have to only look into which orbit it lies. So if it is in the first orbit, then it is h by 2 pi. If it is in the second orbit, it is 2h by 2 pi. If it is in the third orbit, then it will be 3h by 2 pi. That's all about the angular momentum. Okay. Now let's move on to the next one. The radius of an orbit of hydrogen atom is 0.85. So here you can see that the radius is given as 0.85 nanometer. Okay, and you have to calculate the velocity of an electron in this orbit. You have to calculate the velocity. So we know that the radius is equal to, so radius is given as the relation of radius, equation of radius is equal to 0.529 n square by z, right? And that is given as 0.85 nanometer. I am just converting this into Armstrong because 0.85 nanometer means 0.85 into 10 raised to minus 9 meter. Okay, so if I convert into 10 raised to minus 10, then I am getting it as Armstrong. So I can write it as 8.5 into 10 raised to minus 10 meter. That means 8.5 Armstrong, right? It is equal to 8.5 Armstrong. Hope that is clear, right? 8.5 Armstrong. So we will calculate it in Armstrong. So 0.529 into n square. Yeah, what was given? Radius was given, right? Radius is given. So let me rub this off. Got confused. Okay. N square by z. So radius is given as 8.5 Armstrong, that is equal to 0.529 n square. Then calculate the value of electron in this orbit if radius of an orbit of hydrogen atom. See, the orbit of hydrogen atom is given as so we only know the z value. It is hydrogen atom, so z will be 1. We have to find out the orbit, right? So 0.529 into n square by 1. So n square is equal to 8.5 divided by 0.529. Why I converted this to Armstrong? Because this equation, I have told you, if you are using this particular equation, then the radius should be, you are obtaining the radius in Armstrong. So while calculating this, you cannot use any other units. Always use Armstrong. Okay. So now we get the value of n square is equal to, yes, n square is equal to 16. By dividing 8.5 by 5.529, you will be getting a value that n square is equal to 16. So n will be equal to root 16, that is equal to 4. Now you got the orbit as n equal to 4. Now what you have to do? You have to calculate the value of velocity. What is the equation of velocity? Velocity is equal to 2.18 into 10 raised to 6 z by n. Z by n. So we know that 2.18 into 10 raised to 6, since it is hydrogen, the z will be 1. And what will be the value of n? We just obtained it as 4. So divide this 2.18 and 4, you will get the value as 5.545. So 5.45 into 10 raised to 5 you will be getting. Okay, that much meter per second. That much meter per second is the velocity. Hope this is clear, students. Okay, I'll just write the value here, 5.45 into 10 raised to 5 meter per second. Are you getting it, students? Are you getting the value? Okay, now let's move on to the next one. Multiplication of V and R of electron in an orbit is, you have given with 4 options: directly proportional to mass of electron, inversely proportional to. So let's see, we know that multiplication of V and R means there is a relation between MVR, right? So we can write it as MVR is equal to NH by 2 pi. That is the equation we have. So this whole NH by 2 pi we can consider it as constant. So VR is inversely proportional to the mass of electron, right? If you take this M to the RHS, it becomes 1 by N. 1 by M NH by 2 pi. Okay, so VR is inversely proportional to the mass of electron. So B is the right answer. Now let's move on to the next one. The ratio of radius of 2 Bohr orbits of hydrogen atom, 2 Bohr orbits of hydrogen atom is 4:1. Then what would be their nomenclature? Okay, this is an interesting question. First you can write the ratio, first you can write the relation of radius. That is, radius we know that it is n square by z. Since it is hydrogen atom, we know that z equal to 1. So our equation is much more simpler now. So R here, R radius of orbit is directly proportional to n square. So here we know that it is 4:1. So in order to get 4 here, the n value will be 2. And in order to get 1 here, then n value will be 1. Okay. So 4:1 means the orbit will be 2 and 1. So what will be the second orbit? First orbit is K, second orbit is L. So it will be L and K. It cannot be K and L because the ratio here stands as 4:1. So 4 stands for the second orbit, right? N equal to 2. So what is that? That is L. And here it stands for n equal to 1. What is that? It is K. So the value is L and K. So answer is LK. Hope that is clear, students. Yes, I am just looking into your comments, if any comments is coming. Right. No comments till now. Okay. I hope Kundan Das has also left. Right. Okay. Now let's see the next one. So angular momentum of electron is proportional to, we know that angular momentum MVR is equal to NH by 2 pi, right? MVR is equal to NH by 2 pi. And we know that H by 2 pi is constant. This H by 2 pi is constant. So we know that MVR is directly proportional to N, right? N. What is the relation of radius and N? We know that radius is directly proportional to n square by z. Okay. So from here we can consider the relation because z is constant for an atom. Z is constant for an atom. For hydrogen atom z equal to 1. For helium it is z equal to 2. So it is constant for every atom. Okay. So here n square is directly proportional to R means n is directly proportional to root R. From here you can write the relation. So here MVR will be directly proportional to root R. That means, what does that mean? Angular momentum. We know that angular momentum is directly proportional to n. So normally students write it as if there will be one more option, that is it is independent of R. But you have to be aware, this is angular momentum. We know that angular momentum is directly proportional to n, number of orbits, and we also know that the radius is directly proportional to the n square. We have studied that relation, right? So you have to use that relation and you have to apply it here. So n is directly proportional to root R. So same, you can replace the n here, you can replace the n with root R. So angular momentum is directly proportional to root R. So option 2 is the right answer. Okay. Now let's move on to the next question. So this will be the last question. Calculate the ratio of velocity of electron in second excited state. Second excited state means the orbit is n equal to 3. Okay. Of hydrogen atom, and fourth excited state. Fourth excited state means n equal to 5. Now you have to calculate the velocity. We know that velocity is directly proportional to z by n. What is z for hydrogen? That is 1. What is n for hydrogen? That is 3. That is V1. And V2? What is z for lithium? lithium is 3. What is N for lithium? N for lithium is 5. So we have to take the ratio V1 by V2 is equal to 1 by 3 divided by 3 by 5. That is equal to 1 by 3 into 5 by 3. So we get the value as 5 by 9. So that's it, students. That's all about the ratio, that is the velocity ratio of the given condition, that is the second excited state of hydrogen atom means you have to take it as n equal to 3, and fourth excited state of lithium, that you have to consider it as n equal to 5. Okay students, I hope this is clear for you. So this is all about today's class, and if you have any query or if you have any feedbacks, you can just give your comments in the comment box. So if you have any queries, then I'll be more happier to help you in the next session. Okay, so hope your preparations are going well. If you require any help, you can contact us. Okay, then that's all for today's class, students. Hope you enjoyed it well, and all the best for your upcoming exams. Thank you, take care, and bye bye.